Hi, myself Bhuvan Gupta. In this video, I walked you through my web server log analysis project using Python. I cleaned and analyzed Apache web logs from University of Calgary Computer Science web server. There is in first part data loading and cleaning. In second part analysis. And first we have to import the required libraries. Import RE. RE is used for regular expressions to extract the pattern from the text. Pandas are used for handling the structured data for a data frame. And date and time used to convert the log time strings to Python date and time objects. In next step, clean and load the data. Define, load and clean the data of file path is str pd.dataframe. And this line defines the Python function named load and clean the log data. It takes a one input of parameter file path, which should be a string, and representing the path to the log file. It results the pandas data frame containing a cleaned and structured data extracted from the log file. Log pattern define the regular expression to extract the key parts of the each log line. It contains host, data time, method, status, bytes, etc. After next step, to initialize the empty list. It will hold the clean log entities records. It or the records of the clean log entities. One open the log file. Open with use for open the log file. It reads the mode using Latin encoding to handle the special characters. Check if the line matches the pattern. If line matches the pattern, if the line fits a pattern, we extract the data, which extracts the data from it. If match, convert the extracted text into usable data. And group dish and date and time the strip time are used for where the group dictionary makes a dictionary for the matched parts. Date and time converts the data string into Python date and time objects. The next step, to convert types and extract the new information, where it converts the status into integer, converts bytes into integer, converts bytes into integer, converts file from URL, extract the file from extension.html, .jpg, extract hour and date separately for analysis, and then append the cleaned entity records to append the data, add the cleaned record for the list, and convert the data frame pd.dataframe.records. After doing this, load the data set, and it stores the file path of the log file in the variable as like this. Loads and clean the log data into the data frame using custom function. df.logs the head. It shows the top 5 records. It contains host. It contains host, data time, method, URL, status, bytes, file name, txt, hour, date. Check for any non-missing values in each column. There is no missing values in any column. Display the data type for each column. It shows the for method its object URL for the object, status for int, bytes for int, file name, object, etc. It shows all the unique HTTP status codes in the data. It counts how many rows had a 0 bytes transformed. There is 1,56,776 where bytes has transform 0 bytes are transformed. After coming to analysis part, first one, count of total log records. This function calculates the total number of log entities in data frame df of logs. Each row of df of logs represent the one HTTP request made on server. So using this length of log df logs, we count the total number of requests lines in the original log file. This function returns the count of an integer. Finally, the result is sorted in answer 1 and printed. There are 7,280 to our total log records. Count of unique hosts. This returns the number of distant hosts of IP address accessed in server. It uses df of log host.unique. It counts how many unique values present in the host of columns. Each host represents a different user or device made in request. This result tells how many different clients interacted with the server. The final count printed in answer 2. There are the two unique hosts. Data-wise unique file name count. This calculates how many different file names were requested in the each day. It groups the df logs data frame by using the data column. For each data, it counts the how many number of unique files in a unique. It results returned in dictionary while keys contains date values contains unique numbers of unique file names accessed on the date. The answer, where this helps to understanding the daily usage pattern and identifying the peak activity days, where it contains date and value. Number of 404 response errors. This calculates counts the how many times 404 found error occurred in the log data. It checks where the status column. It checks the status column and the df logs of equal 404 using the condition. If the df log status 404, then it uses .sum to add up all the true values which are treated as 1, giving the total number of 404 errors. This is usually used where it tells us how many broken or missing page requests happen on the server. There are 23,440 broken and missing servers. In fifth one, top 15 file names with 404 response. This identifies the file names of URL triggered the most 404 errors. The first it filters the log data to include the rows where the status code 404. It filters while using this. Then it's count how many times each file appeared in those 404 errors. That values are count. It takes top 15 frequent file names with .head to convert the result into the list to tuple using the .items, and it helps to identify the missing resources like page.html, log, png, the most often requested but not found. The answer, index.html 4062, where the files which are 404 response. Top 15. These are the top 15 where the 404 response. top 15 file extension with 404 response, and finds the which file type by extension HTML, JPG, .gif, etc. It first filters the dataset for the 404 for code using filters df.log of df logs status is called 404. Then it counts the frequency of each extension using values.count. Then it selects the top 15 extensions and converts the list of tuples to items. This analysis is useful to identify the which type of files, example images, base graphs, are commonly missing for the server. Their HTML, the top 15 extensions with 404 response. These are the top 15 files with 404 response. Contains HTML contains 121.39, GIF contains 7202, XPN 824, so on. Total bandwidth transfer per day for the month of July 1995. This function calculates how many data bytes were transferred each day in the July 1995. It first filters the log data, include only the entity of the July 1995. Then it groups the data by the date column. Then for each date it sums up to the bytes transformed. The result is returned as dictionary like example 1 July 1995 and value. In this, the bandwidth transfer per day month of 1995 were in 1st July 1995 1333976 are transformed, one in 2nd July 1995 856369 3986 865 3986 are transferred, so on. Hourly request distribution. This function calculates how many requests are made during each hour of the day from 0 to 23. It uses the hour column to log the data frame. The values count are calculated how many requests occurred in each hour, and sort index is hours are in order from the 0 to 23. Finally, it returns the dictionary 0, example 0 is to count, 1 is to count at 20, so on. It helps to identify the peak traffic hours of the server. 0 the output of this question is 0 is to 18, 5605, 14 is to 86, 2 is to 12624, 3 is to 10850, so on. Top 10 most requested file names. This function finds the top 10 most frequently requested file names from the log data. It uses to values count on the file name on column to count how often each file was requested. Head of 10. Select the top 10 file with the highest request counts. Items. Items. It returns into the list of file name count of base. Top 10 most requested files. These are the top 10 most requested files: index.html 1395053, 3.jfs 2006, 2.jfs 23195, so on. HTTP response code distribution. This function calculates how many times each HTTP response status code appears in the web server log. It uses the values count on the status column to count often each status, like 200, 400, 403 errors, etc. errors, to To dictionary, convert the result into dictionary for each lookup and analysis. This helps us to understand the overall success and error patterns in the server response. The output of this question is 200 566 138 304 997 560 and 404 23440, so on. Thank you for this. Thank you for watching. Thank you for your time.